Okay, now we have, in the case of this problem, we're looking at working with the function y is equal to the square root of 16 minus x squared, and we're looking at determining the volume of the solid generated about the y-axis. And so for what we have here, you have perpetual contact between the graph of y is equal to the square root of 16 minus x squared and the y-axis. Okay, so you're going from the route from y is equal to 0 to y is equal to 4, and we will be able to use the method of disks. And so to be able to use the method of disks, we need to integrate over y, and so to make the function integrable over y, we need to rewrite this in its equivalent form, namely x is equal to the square root of 16 minus y squared. And so for the setup that we have here, it's going to turn out that for what we have in the solid that's going to be generated, okay, the radius is going to be equal to the square root of 16 minus y. And in terms of generating the solid about the y-axis, okay, this is going to be a hemisphere, and again, I have already drawn the disk, and so we have for the radius, again, that is going to be the square root of 16 minus y squared. So you have solid contact with the y-axis, so you have a solid region throughout for this object. Okay, now for the volume about the y-axis, okay, again, we're going from, in this case, from y is equal to 0 to y is equal to 4, top to bottom. The radius we have at the square root of 16 minus y squared, and in the case of generating the volume, okay, and using the method of disks, so again, you're thinking of using the circular area, pi r squared. And so for the volumetric setup, we have that v of y is equal to the integral of pi times the square root of 16 minus y squared dy as y proceeds from 0 to 4. And as we square out the radius, okay, this will eliminate the radical, and so creating what we have here, we have going from 0 to 4, we have the integral of pi times the quantity of 16 minus y squared dy, and in the follow through, if we take the power rule of integration, okay, we now have pi times the quantity of 16y minus y cubed over 3 as y goes from 0 to 4, and at 0, the lower limit, okay, the expression is negligible, and in the case of what we have for y is equal to 4, okay, that upper limit is going to generate the value of the volume of the solid about the y-axis, and we have in exact terms the result at 1/28 pi.